Welcome to 7th grade math. List the first 10 multiples of each number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 2, we have 4, 6, 8, 10, 12, 14, 16, 18, 20. For 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. For 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Does this look familiar? It is the multiplication table. These are actually the first positive multiples of each number. So 0 is a multiple of all numbers. And negative numbers are also multiples of numbers. In listing multiples, we listed natural numbers. Natural numbers are positive whole numbers, 1, 2, 3, etc. Minilab, use cubes to build the first row of 2 prisms. Add a second row to each prism and record the total number of cubes in the table below. So prism A had 4, and we just added 4 more, so now we have 8. Prism 6 had 6, and we just added 6 more to make 12. Add rows until each prism has 4 rows. So we're going to add 4 more to prism A to get 12, 6 more to prism B to get 18, 4 more to prism A to get 16, and 6 more to prism B to get 24. Describe the prisms that have the same number of cubes. Both prisms have the same number of cubes when prism A has 3 rows and prism B has 2 rows. And that's the least common multiple. If you keep adding rows, will the 2 prisms have the same number of cubes again? Yes. Every third row in prism A will have the same number of cubes as every second row in prism B. And that's common multiples. Multiple, the product of a number and any whole number. Least common multiple, or LCM, the least of the common multiples of 2 or more numbers excluding 0. Examples, find the LCM, least common multiple. Find the least common multiple of 6 and 10. So method 1, we can list the non-zero multiples and list the multiples of 6 until you come to a number that is also a multiple of 10. So multiples of 6, 6, 12, 18, 24, 30. We know 30 is a multiple of 10. So multiples of 10, 10, 20, 30. And our least common multiple is 30. Method 2, we can use prime factorization. 6, 2 times 3 are the prime factors of 6. And the prime factors of 10 are 2 times 5. So the prime factors of 6 and 10 are 2, 3, and 5. The least common multiple is the least product that contains the prime factors of each number. So the least common multiple of 6 and 10 is 2 times 3 times 5, or 30. Maria has a collection of quarters, dimes, and nickels. In order to count the coins, she wants to make several piles of each coin that are equal in value. How many dimes equals 2 quarters? There's 2 quarters, and it equals 5 dimes, right? 50 cents equals 50 cents. How many dimes equals 6 quarters? There's 6 quarters, so we have $1.50. So how many dimes would that be? 15 dimes would equal $1.50, or 6 quarters. How many nickels equal 1 dime? Well, 1 dime is 10 cents, so 1 dime equals 2 nickels. And how many nickels equals 4 dimes? So 4 dimes is 40 cents, so how many nickels goes into 40 cents? 8 nickels. Least common multiple. A set of numbers is the least product that contains the prime factors of each number. One way to find the least common multiple of a set of numbers is to list their non-zero multiples. So list the non-zero multiples of 5 and 9. So 5, we have 5, 10, 15, 20, 25, 30, 35, 40, 45. Then the non-zero multiples of 9 are 9, 18, 27, 36, and 45. Notice that 45 is a common multiple of 5 and 9. And it is the least common multiple as well. Another way to find the least common multiple of a set of numbers is to write each number's prime factorization and then multiply the greatest power of each prime factor. So list the prime factors of 5 and 9. 5 is 5. 9 is 3 times 3, or 3 squared. The least common multiple of 5 and 9 is 5 times 3 squared, or 45. Examples: find the least common multiple of 45 and 75. Use method 2, find the prime factorization of each number. So for 45, we get 3 times 3 is 9, times 5 is 45. And for 75, we get 3 times 5 is 15, times 5 is 75. Or if you wanted to go about another way, 5 times 5 is 25, times 3 is 75. So we can rewrite 3 times 5 as 3 squared times 5. And then we can rewrite 75 as 3 times 5 squared. And we're going to take 3 squared and 5 squared. The prime factors of 45 and 75 are 3 and 5. Write the prime factorization using exponents. So the least common multiple is the product of the prime factors 3 and 5. With each one raised to the largest power, it occurs in either prime factorization. So we're taking 3 squared because it's larger than 3, and we're taking 5 squared because it's larger than 5. So the least common multiple of 45 and 75 is 3 squared times 5 squared, which is really 9 times 25, which is 225. Choose your method. Find the least common multiple of 3 and 12. So list the non-zero multiples. 3 is 3, 6, 9, 12. And 12, we can stop at 12 because that's going to be our least common multiple. And the least common multiple of 3 and 12 is 12. Use method 2, find the prime factorization of each number. So 3, the prime factors are 3. And for 12, the prime factors are 2 times 2 times 3. So the prime factors of 3 and 12 are 2 and 3. Write the prime factorization using exponents. So we're going to have the least common multiple of 3 and 12 is 2 squared times 3, which is 12. Choose your method. Find the least common multiple of 10 and 12. Use method 1, list the non-zero multiples. So 10's non-zero multiples, 10, 20, 30, 40, 50, 60, etc. And 12's non-zero multiples are 12, 24, 36, 48, 60. We can stop there because we can see we have a common multiple. So the least common multiple of 10 and 12 is 60. Use method 2, find the prime factorization of each number. So for 10, the prime factors are 2 and 5. And for 12, the prime factors are 2 times 2 times 3. The prime factors of 10 and 12 are 2, 3, and 5. Write the prime factorization using exponents. So we can list 10 as 5 and 12 is 2 squared times 3. And the least common multiple is the product of the prime factors 2, 3, and 5, with each one raised to the largest power that occurs in either prime factorization. So 2 squared happens more than the 2. And then we have the 3 and the 5. So if we multiply those together, 2 times 2 is 4, times 3 is 12, times 5 is 60. Find the least common multiple of 25 and 30. So the first method is we'll list the non-zero multiples. So 25, 50, 75, 100, 125, 150. And then for 30, we'll list the multiples 30, 60, 90, 120, 150. 150 is the least common multiple of 25 and 30. So now we'll use prime factorization of each number. 25, we have 5 times 5. And 30, we have 2 times 3 times 5, because 6 times 5 is 30. And the prime factors of 25 and 30 are 2, 3, and 5. Write the prime factorization using exponents. So we have 5 squared for 25, and then for 30 we have 2 times 3 times 5. So we're going to use 2 times 3 times 5 squared, because 5 squared is the largest exponent for 5. So we have 2 times 3 times 5 squared, which is 6 times 5 times 5, which is 6 times 25, which is 150. Real world example, Ling needs to buy paper plates, napkins, and cups for a party. Plates come in packages of 12, napkins come in packages of 16, and cups come in packages of 8. What is the least number of packages she will have to buy if she wants to have the same number of plates, napkins, and cups? So we are going to find the least common multiple of 8, 12, and 16. 8 equals 2 times 2 times 2, or 2 cubed. 12 equals 2 times 2 times 3, or 2 squared times 3. And 16 equals 2 times 2 times 2 times 2, or 2 to the 4th power. So we have 3 different values for 2 that we can take. Which one do you think we'll take? We're going to take 2 to the 4th power, because that's the highest power of 2's. And then we're going to take that 3 as well. So we have 2 to the 4th power, which is 16, and then times 3, which is 48. To find the number of packages of each Ling needs to buy, divide 48 by the amount in each package. So 48 divided by 8 needs 6 packages of cups. 48 divided by 12 need 4 packages of plates. And 48 divided by 16, or 3 packages of napkins. So Ling will need to buy 6 packages of cups, 4 packages of plates, and 3 packages of napkins. Mr. Hernandez has a schedule for getting his car serviced. Changes the oil every 3 months. Rotates the tires every 6 months. And replaces the air filter once a year. If he completed all 3 tasks in April, what will be the next month he again completes all 3 tasks? So what do you think we need to find in order to find the answer to this? It's correct. The least common multiple of 3, 6, and 12. Now you may already have an idea what that least common multiple is, but let's go through the steps. So the prime factors of 3 is 3. The prime factors of 6 is 2 times 3. And the prime factors of 12 are 2 squared times 3. So the least common multiple of 3, 6, and 12 is 2 squared times 3, which is 12. Mr. Hernandez will need to do all 3 maintenance items 12 months from April, so he will get all 3 items serviced again the following April. Additional examples. Find the least common multiple of 4 and 6. That's 12. Find the least common multiple of 4 and 15. 60. On an assembly line, machine A must be oiled every 18 minutes. Machine B must be oiled every 24 minutes, and machine C every 48 minutes. If all three machines are turned on at the same time, and how many minutes will all three machines need to be oiled at the same time? So we're going to look for the least common multiple again. And 18, our prime factors are 2 times 3 squared. 24, our prime factors are 2 cubed times 3. And 48, our prime factors are 2 to the 4th times 3. So if we pull out the highest power for each number, we have 2 to the 4th power times 3 squared, or 144 minutes. There's your homework for today. Head over to Google Classroom to submit it, and I hope you have a great day.